All right, here's section 11.3, still part of Unit 10 on the arc lengths. Area circles and sectors. So we're going to do area circumference, length of arcs, and areas of sectors, which are just parts of a circle. So in order to do this section, you need to have the formulas. So there's two formulas for circumference, both the same thing. We have circumference is equal to pi times the diameter. Diameter is also two radiuses, so you can see it as two radiuses as well. And the area is pi r squared. Again, the radius is the shorter of the two, coming from the center to the outside, while the diameter runs through the entire circle. Okay, so the first part here, we're going to look at circumference and area of a couple different circles, and then we're also going to look at the exact value compared to rounding it. So for this particular example 1, we have a radius of 8. So our radius is 8. So in order to get the area, we would do pi r squared. So that would be 8 squared times pi, or 64 pi. That is the exact value using pi. So if you have pi in your answer, you do have the exact value. So that would be 64 pi. Circumference would be twice the radius, so we would multiply it by 2, we'd get 16, and again we just attach a pi to it. So those are the exact values. When we go to find the nearest hundredth or tenth, we need to use an approximation of pi. So we're going to use 3.14 for pi and multiply 16 by 3.14 and 64 by 3.14. So when you multiply 16 by 3.14, 16 by 3.14, we get 50.64 or 24. Where's that? And then 64 times pi, 64 times 3.14 is 200.96. Okay, so then in terms of rounding, again, you have to just know your decimal places. So the first place is the tenths, the second is the hundredths. So for the hundredths, we're going to write down the answer we got, 50.24, 200.96. For the tenths, we're rounding to this second number, so we look at the third to determine what's going to happen. So here on 50.24, the 4 is less, so we just round and cut it off, so 50.2. In this one, the 6 is larger than 4, so 5 or bigger makes it round up, so we're going to round the 9 up. The 9 gets rounded to a 10, so it actually will turn this whole thing into 201.0. On to example 2, here we've got a diameter of 8. So for the circumference, we can just go directly to it. It's going to be the diameter times pi for our exact value. In order to get the area, we need the radius. Radius is half of the diameter. Okay, so the radius is 4. So we end up with 4 squared pi for our area. So that becomes 16 pi. Using our workflow on the example 1 for 16 pi, we can copy that down. We've got 50.2 and 50.24 for our two answers. Here we're going to have to multiply 8 by 3.14. And we get 25.12, so it's half of this. And again, if we round to the nearest tenth, that's to the first decimal place. The 2 does not make the 1 round up. So again, for multiplying by pi, you just take the number and you're going to multiply by 3.14. And that's how we can get these answers. All right, so the next is sectors of circles. And so sectors are just part of a circle. Okay, so you either have an area of a sector or the length of an arc within a circle. So all of it has to do with how many degrees it is. There's 360 degrees in a circle. So anything less than 360 degrees would give you that percentage of the circle. So you just need to make sure that you are looking at what that particular degree measure is. You divide it by 360, multiply by the formulas we just used. Okay, so here's our formulas up here for each one. Each one we need the arc degree, and then we either multiply by our area formula or our circumference formula. Okay, so example 3, we have 60 as our arc length. So for our arc length, we're going to have the L is equal to 60 over 360. And then here we have a radius of 6. So then we multiply by 2, pi, and 6. Okay, so then that turns into 1 over 6 if we reduce it. Dividing both by 60, we get 1 over 6. 2 times 6 is 12, so times 12 pi. And here, if we put this together, we get 12 over 6. 12 divided by 6 is 2, so that's going to equal 2 pi. So our arc length is 2 pi. And then for the area, we're going to do the exact same thing. So we're going to still use this 1/6, which comes from the 60 over 360. And we're going to do pi, and now we need to the radius squared. So we'll do 6 squared. So we end up doing 1/6 times 36 pi. Once again, if we take this 36 and put it over 6, that's going to give us 6 pi. So that's our sector area, 6 pi. And we're going to multiply both those numbers by 3.14. So 2 times 3.14 is going to give us 6.28. And now the 8 will round the 2 up, so to the 10th we'll have 6.3. And then for the sector, we're going to have 6 times 3.14. And we get 18.84. And the 4 does not make the 8 round up, so we're going to have 18.8 as our rounded to the nearest 10th. Okay, so for the next one here, again, we've got radius of 8. And here, this one is 240, but we're looking for this degree over here. So since there's 360 degrees in a circle, we can just subtract the 240 from it. So we end up with 120. So that's going to be our fraction that we're going to create. So 120 over 360. And if we divide both those by 120, we're going to get 1/3. So we're looking for 1/3 of everything. Okay, so for our circumference, or arc length, we're going to use our circumference. So we need 1/3 of the diameter times pi, which is going to be 2 times 18. So we end up with 16 over 3 pi. That'll be our exact value here, so 16 over 3. Okay, and we can put the pi on top. And then for our sector, we're going to do the same thing, 1/3, except now it's going to be the radius squared times pi. So this is going to be 64 divided by 3 pi. I can't divide 64 by 3, so we're going to leave it as 64 pi over 3. And so now multiplying this, you're going to want to multiply 16 times 3.14. And then once you do that, divide the result by 3. So that's going to give us 16.746. So when we're rounding to the nearest hundredth, we're going to go to 16.75, and then to the nearest tenth here we'll go to just 16.7, because we don't want to use our already rounded answer. We're going to use our answer down here, and the 4 doesn't make the 7 go up. Okay, for the next one we'll do 64 times 3.14, and then we will divide that result by 3, and we get 66.986. So the 6 will make this round up to 66.99. The 8 will make this round up so it becomes 67.0. Okay. 2 more examples here. So here we've got a radius of 16. Here we've got that little box which indicates a right angle. So that means this is 90 degrees. So in order to find the arc length we need, we're going to subtract 90 from 360. We get 270. 270 over 360. If we reduce that, we get 3 over 4 by dividing both of them by 90. So both our equations are going to have 3/4 attached to them. So 3/4 times 2 times our radius of 16 times pi. So 32 times 3/4. So we have 3/4 times 32 pi. So we multiply the 3 and the 32. We get 96 divided by 4 times pi. And 96 divided by 4 is 24. So we have 24 pi for our arc length. And we'll get a much bigger number for our sector area because we're going to be squaring 16. So we have 3/4 times 16 squared. So this is the sector area times pi. 16 squared is going to give us 256. So 3/4 times 256 times pi, and 256 times 3 is 768 divided by 4 pi, and 768 divided by 4 leaves us with 192. So we'll have 192 pi as our sector area. And this was our arc length. Okay, so we'll do 24 times 3.14. And we end up with 75.36. And that would force us to round the 3 to a 4. And 192 times 3.14 is 602.88. And this would make us round the first 8 to a 9. Okay. Alright, so then the last problem here, we have to find the radius, and we're given the area of a sector. So we need that formula. So the area, the sector area, is going to equal our arc degree. Okay, so we'll use our exact formula here. So we have our arc over 360. So our arc degree over 360 times pi r squared. We don't know r. We're going to find r. Okay, we know that we have 120 for this, so we have 120 over 360 pi r squared, and that's going to equal 12 pi. So the first thing we could do, since we have pi on both sides, is cross it off so we don't need to worry about it. Secondly, we can reduce our fraction. Dividing both by 120 gives us 1/3. R squared is 12. In order to solve for r, we need to get rid of the fraction, so we'd multiply by 3 over 1, the reciprocal. So 3 times 12 is 36. That equals r squared. And to get rid of r squared, we take the square root. Normally we get plus or minus 6, but since our radius can't be negative, our answer has to be 6. So 6 centimeters for our radius. And that concludes the notes on finding arc lengths and sector area.